Hello everyone, I am Elvis and I want to welcome you all to the World Challenge Club Educational Show. This week, we're investigating the fascinating world of water and water power. If you haven't heard about the World Challenge Club, let me tell you. It is a place where you can do fun and exciting experiments while learning new things. There is also an online competition you can take part in to win certificates and prizes. You can even join with your classmates to make teams, so come and join the fun. If you like making things or taking them apart to see how they work, then the World Challenge Club is for you. If you're already a club member, have you been trying out some of the previous challenges and putting your scores on the World Challenge Club leaderboard? Each show has a new challenge for you to complete after. And to do these challenges, you'd only need to use things that you can find in your home. For example, plastic bottles, rubber bands, paper, or bits of string. You can recycle spare things you may have around. Remember, each challenge you complete will give you a score. If you do well in a challenge by testing and improving your solutions and ideas, you will get better scores. The theme for this week's challenge is water and water power. And today's challenge is to make a rubber band powered speedboat from an old plastic bottle or food container. The faster you can make it go, the better your score. You will learn about things like elastic potential energy and streamlining. If anything sounds complicated to you, it won't be by the end of the show. We will also teach you any skills that you need to tackle each day's challenge. And we have people like Shad, our master of mathematics from Charismath, to help explain it all. Science and technology help us every day, from how we move the things that we need around over land and sea to generating the power that gives us electric lights and television. We will be exploring some of these ideas today and throughout the rest of the week. Would you like to play a part in making the world a better place? For that, you need to learn, understand, and apply science, technology, engineering, and mathematics, or STEM. STEM skills help you to learn and understand the world better, so you may do better, think, act, and feel better. To turn dreams and ideas into reality, we have to change our hidden abilities into skills, our secret curiosities into knowledge. That's what makes people's lives easier, safer, and enjoyable. One group of people that use their STEM skills to invent amazing power systems for boats and ships are the designers and scientists and engineers at Rolls-Royce.
Hello, I'm Dr. Helen Taylor and I work at Rolls-Royce. Rolls-Royce make turbines for planes and boats, but the bit that I work for makes nuclear engines for submarines. And I'm a metallurgist or a materials engineer. So I'm part of a team that makes sure the materials in the engine of submarines won't break when it's being used. I was interested in how things work. I enjoyed school and I was really good at maths and science, which are two of the building blocks of engineering. I studied mechanical engineering, which is concerned with designing things and making things that go, like cars. I did a PhD or a doctorate, which is why I'm Dr. Helen Taylor, and I did that in laser welding aluminium. But engineers need to consider the future, whether that's renewables, increasing fuel efficiency, electric planes, new materials, or 3D printing. Engineers need to think about things that move us forward, but also do less harm to the environment. Engineering is a great career. There are lots of jobs and a wide variety of roles to do, whether that's doing materials engineering and finding out all about different materials, whether it's mechanical engineering and designing a car, or civil engineering designing a road or a bridge, or electrical engineering and designing the electrics in the inside of building, or chemical engineering and working in the gas and oil industry. There's so many different jobs, and even if you're a mechanical engineer, there's so many different things to do and you can do loads of different things. I've worked with lasers, doing laser welding. I've worked with diggers and I've driven diggers. And now I work with submarines and been on submarines. There's so many things you can do. I did quite a broad degree with mechanical engineering, but even now that I've specialised, there's still a wide variety of companies to work for. There's loads of different opportunities. I've just started doing more work supporting making parts and manufacturing. I'd like to do more of that and also carry on getting involved in welding. That's what I did my doctorate in. welding, so I like welding and getting more involved in that. I think there's a need to go more low carbon. There might be more electric ferries. I think for cargo ships and things, they're probably going to get bigger to get more efficient, because then you can get more in. But maybe there'll be nuclear because that's low carbon, and you don't need to keep charging it or plugging it in. It will just keep going.
This takes lots of power and energy. The less energy these ships can use, the better for the environment. Companies like Rolls-Royce and the people working there are busy inventing futuristic ways of powering ships and boats. Today, you will make your own power system for a moving model boat using just the energy you can store in a rubber band. A rubber band is like a spring. Let's start our educational journey today by learning a little more about how energy can be stored in a spring with a video from Twig Education.
All these devices are powered by batteries. Batteries are an important source of electricity. Things powered by batteries don't need external wires or plugs. We can use them almost anywhere. It's the chemical energy in the batteries that produces the electrical energy needed to power the machine. In this case, producing light energy. This electrical energy can be changed into many different forms of energy. For example, sound energy for radios. But batteries don't last forever. When the chemicals are used up, the batteries become flat and stop working. This was a problem for people in remote parts of the world, who use radios to receive important information. In these remote areas, there is little or no access to mains electricity and limited access to batteries. The people living here need a radio that does not need an electrical supply to work. An inventor, called Trevor Bayliss, created the world's first wind-up radio. Trevor combined a radio with a clockwork mechanism. This clockwork mechanism contained a spring which could be wound up by hand, storing potential energy. The spring has the potential to unwind and release the energy stored within. As the spring unwinds, the potential energy creates movement, or kinetic energy. The kinetic energy is converted by the generator into electrical energy, which powers the radio. The world's first wind-up radio was born, meaning that the people who live in the most remote parts of the world are now able to receive important information from radios without using mains or battery-produced electricity.
You have learned that energy can be stored in something like a spring or an elastic rubber band. This energy can be released later and turned into other forms of energy, such as rotational energy to spin a paddle wheel or kinetic energy from movement. You will use these ideas to make a power system for a model speedboat. After the break, you will learn more about the Rubber Band Speedboat Challenge and how to test and improve your speedboat designs. Remember, your best design may even get a top place on the World Challenge Club leaderboard. If you're not yet a member of the World Challenge Club and you have a smartphone, you could sign up and be ready to start earning points to go towards prizes and certificates. I will see you soon after the break. Have you got something that you have made for one of our challenges that you would like to share and see on the show? First, check with your parents and then send us a picture on WhatsApp along with your first name, school and country to +44 744-096-3443 or by email to elvis@worldchallenge.club. We can't wait to see what you have made.
COVID-19 is an infectious disease caused by a new coronavirus introduced to humans for the first time. It is spread from person to person, mainly through the droplets produced when an infected person speaks, coughs, or sneezes. These droplets can land in the mouths or noses of people who are nearby. These droplets are too heavy to travel far in the air. They only travel approximately 1 meter and quickly settle on surfaces. This is the reason person-to-person spread is happening mainly between close contacts. The exact time that the virus can survive on surfaces is not yet known. So it is wise to clean surfaces regularly, particularly in the vicinity of people infected with COVID-19. Hands touch many surfaces, which can be contaminated with the virus. You should therefore avoid touching your eyes, nose, or mouth, since contaminated hands can transfer the virus from the surface to yourself. When coughing or sneezing, cover your mouth and nose with the bend of your elbow or use a disposable tissue. If a tissue is used, discard it immediately into a closed bin. The most effective way to prevent the spread of the new coronavirus is to clean your hands frequently with an alcohol-based hand rub or soap and water. This will eliminate the virus if it is on your hands. Stay healthy and prevent the spread of COVID-19.
Welcome back to the World Challenge Club. Are you ready to learn some more? Today's challenge at the club is to make a rubber band powered speedboat. You will capture energy in a rubber band and then release it to power a speedboat that you make from old bottle or tub to go as fast as it can. Let's take a close look at how you can do this.
Humans have relied on the wind to propel their boats and ships for thousands of years. But when there was no wind, they only had their own muscle power. To cross an ocean, they would need more. With the development of steam power in the Industrial Revolution, the energy stored and hidden in coal or oil was harnessed and could be turned into power to move things. Humans could now travel and transport things anywhere and whenever they wanted. Your challenge today is to harness the energy you can store in a rubber band to move a cargo boat that you will make from an old plastic bottle or recycled food container. When you store energy in a rubber band, it is called elastic potential energy. For this activity, you will need a nice clear space to work, some scissors and a ruler. You can use old plastic bottles or food tubs for the hull of your boat, and pieces of recycled plastic or lolly stick to make paddles or propellers. You will need some small sticks or rods to act as propeller shafts, but could use pens or pencils for those. You should pick a rubber band that is around 10 centimetres long when unstretched and about 5 millimetres thick. If you only have thinner or shorter rubber bands, you can combine them to make them similar. You will need a good sized bowl of water to test your rubber band cargo boat. A bath or a large tub is ideal. It should be big enough so that your boat can travel forward at least 20 centimetres. You will need a stopwatch to time your cargo boat. This could be an app on a phone. Make sure you keep anything electronic away from the water though, and ask for help if needed. Finally, you will need some cargo. 250 grams of small stones or gravel would be ideal, but you could use glass beads or plastic toys that you don't mind getting wet. You could use a beam balance if you've made one to weigh this. Check your bottle or tub you want to use is big enough to float with your cargo in. You can store energy in a rubber band by twisting it. You can use the twist to grip and hold a paddle. Here is an example of a boat made using a twisted rubber band. The rubber band is held with 2 rods attached to the hull. You can also stretch and wrap a rubber band around a rod or shaft to store energy. When the rubber band unwraps, it will turn the propeller shaft and any paddles attached to it. This design uses a stretched rubber band wrapped around the propeller shaft. The rubber band has been cut to make it longer. You are allowed to do this. When you have a working rubber band cargo boat loaded with 250 grams of cargo, it's time to test it. Find some water big and deep enough for your boat to travel at least 20 centimetres to a finish line. Store the energy in the rubber band and start timing when you release it. Stop when the boat reaches the finish line. You will have a time. Keep a good record. Experiment with different shapes of hull and propeller system. Your first design may not be the best. Which hull shapes might cut through the water better? Test different ones. You want to find the most efficient design, the one that can use the energy stored in the rubber band the best. To get our final score, we will need to work out the average speed of your boat. A higher average speed is better. To do this, we divide the distance it travelled, in the last test it was 20 centimetres, by the time it took in seconds. You can use a calculator if you want. This will give you an average speed in centimetres per second, and that is your score.
So now you can see how to make a rubber band powered speedboat. But how can we measure how fast it goes, its velocity? We will need that as your score to go onto the leaderboard. Here is Shad, our master of mathematics from Charismath, who will explain time, distance, and speed.
What is speed? Well, let's find out. Here's a tub full of water, and there's a boat here which has propellers, and it's going to cover a certain distance in a certain time. So this covers a distance of 20 centimeters in 5 seconds. And this one covers a distance of 20 centimeters very slowly in exactly 10 seconds. There we go. So if we show this on a scale, this is what it did. 5 seconds it took for 20 centimeters, 10 seconds for 20 centimeters. So if we show that as 20 centimeters in 5 seconds, 20 centimeters in 10 seconds, then we can think about the speeds. If we can work out how fast they went in 1 second, what's the distance this traveled in 1 second, we get the speed right away. So divide both of them by 5, and we get the answer 4 centimeters in 1 second. And that's because you're dividing the distance by the time, 5 seconds. You'll do the same thing here. Divide the distance here by the time, 10 seconds. If we find the distance in 1 second for this boat, divide both by 10 this time, so that it reduces always to 1. So divide this by 10, and we'll get 2 centimeters in 1 second. And so we want to show this here, 4 centimeters in 1 second, 2 centimeters in 1 second. Let's reorganize this so that it looks nice and elegant. There it is. Speed is distance over time. That's 4 centimeters per second. 2 centimeters per second means 1 second. Divide the two, you'll get the distance traveled in unit time, which means in 1 second, or 1 minute, or 1 hour, or 1 week, or 1 month. It has to be 1 something. There you have it. Now see if you can figure out this. This cyclist covers a distance of 3 kilometers in 6 minutes. You got that? Okay, we'll show that on a grid. And this jogger covers a distance of 5 kilometers in 50 minutes. Okay, let's show this data here. How fast do they move? Well, the distance traveled here is 3 kilometers in 6 minutes, and the jogger here is 5 kilometers in 15 minutes. We know what to do to find the speed. Divide the two, 3 kilometers divided by 6, and then 5 kilometers divided by 50. And since they're in kilometers, we can change this into meters. We get larger numbers. So like 3,000 meters, 5,000 meters. Now it's easy to divide the two. So it comes to 500 meters per minute. And we have both the speeds. There you go.
After the break, we will visit the lab to see how Jazz tackled the challenge. I will see you shortly. Have you got something that you have made for one of our challenges that you would like to share and see on the show? First, check with your parents and then send us a picture on WhatsApp along with your first name, school and country to +44 744 096 3443 or by email to elvis@worldchallenge.club. We can't wait to see what you have made. Welcome back to the third segment of the World Challenge Club. Here is Jazz in his lab to show us how he tackled today's rubber band speedboat challenge.
Hello and welcome to the lab. Your challenge today is to use the energy you can store in an elastic band to power a rubber band powered boat that can carry 250 grams of cargo. Your rubber band should be around 10 centimetres long and 5 millimetres thick. You can combine smaller ones to make them a similar size. You will need a tub, sink or bath of water big enough so that your boat can travel forward 20 centimetres. You will divide the distance it travels by the time it takes to work out the average speed, and that will be your score.
So what we're doing today, we are making a rubber band powered boat. 3, 2, 1. For that you'll need a container, scissors to cut my axles, rubber band, something to make your paddles or propeller with, cocktail sticks for the axles. I'm using some bottle tops here. So the first thing you need to do is get your box and make holes to accommodate your axle. That one at the back for the paddles and one at the front to hold the elastic band onto it. Make sure you leave enough distance so you can get a nice tension for your boat. Push it through. Push it through there. And when you do use a container, make sure it's strong enough to withstand the pulling force of the rubber band. So don't use something really flimsy. So you can see the first cocktail stick will go through there. Like so. Then on the front one is well secure the elastic band. Like so. You probably need to enlarge the back hole slightly because you can see there's some friction. You don't want any friction there at all. So the next stage is to get the paddles on. You can see I've done one already. Paddles being put on. Use one bolt top there as a spacer and use a larger one to have the paddles attached to it. So you can see it's moving freely. And I'll show you how to do it on the other side. So the milk bolt top there, I'll just push for it. It's not stuck on at all. And what I'm going to do first of all is get my other milk bolt top. I'm pushing that through there for the time being, but I'm not sticking it to the other one because I don't want it stuck on at all. Because this will be secured to the axle while that is free running. The next stage is to get your other ones. And what I'm going to do is stick them onto the other side. So now you can see that both paddles are on the boat, moving on freely. I've also attached the front beam there, and that's where our elastic band will be secured. So we've got an elastic band there, and you want to cut it in half, like so. Then we're going to secure it on one side by putting a knot in it. So that's secured there nicely. And next thing is to secure the other side. So you can see how nice that is. In the water, ready to launch. 3, 2, 1. Into the water, paddles there, and see what happens. 3, 2, 1. You can see it hasn't gone as fast.
Design the best boat that can carry 250 grams of cargo, time it over 20 centimetres, and then use the calculation distance divided by time to work out your score.
We are nearly at the end of our show, and it's time to review everything before you go and have some fun making and testing your own rubber band speedboats. So what have you learned? You can store energy in something springy like a rubber band. This energy can be released to drive something like a paddle that can make something move. You have also seen that by knowing time and distance, you can work out speed. You will need that to calculate your score. Before you go, let's remind ourselves of the rules. For your rubber band speedboat, you can use an old plastic bottle or old plastic food tub. The choice of which shape and which modifications you do is all up to you. You should use one rubber band that is around 10 to 12 centimeters in length and 4 to 5 millimeters thick when unstretched. If your rubber bands are very thin, you can use 2. Do try different designs and think about which shapes will help your speedboat cut through the water. Scientists and engineers capture data to help them make their decisions. You should do the same. Keep notes about which shapes and designs of boat and paddle or propeller work best. Keep a record of your very best score and enter it onto the leaderboard at worldchallenge.club at the very end of the day. If you're not signed up to the World Challenge Club yet, here is how you can. We can't wait to see those scores.
If you want to see anything that was in the show again, go to www.worldchallenge.club. The World Challenge Club will work on any computer, tablet or smartphone that can connect to the internet. There are extra resources there too, so you can learn even more. The World Challenge Club is also a giant competition for hundreds of thousands of students from around the world. To take part in the competition, you'll need to sign up and become a member. You only need to register once, but you must check with a parent or teacher first before you sign up. If you're under 14 years of age, they will need to include their email address too. So go to www.worldchallenge.club and look out for the green register button on a challenge page. Just click it and follow the instructions. You'll be asked to find your school and join a team. When you've signed up, you'll be able to upload your best score for each day's challenge. So after the show, check out the club and get uploading your scores. We can't wait to see how you do on today's challenge. Have you got something that you have made for one of our challenges that you would like to share and see on the show? First, check with your parents and then send us a picture or a video clip on WhatsApp along with your first name, school and country. Or you can email elvis@worldchallenge.club. We can't wait to see what you've made.
105 rooms.
You have seen how to use the club website, and hopefully you have everything you need to know to have a go at the Rubber Band Cargo Boat Challenge and have some fun. Remember to keep a good record of the amount of cargo your boat can carry so that you can enter your best score on the club website. Before we let you go off to make some boats, there are a few people and organizations we must thank. Today's educational show was made possible with the kind support of Rolls-Royce. Rolls-Royce is a world-leading technology company and maker of power systems including engines for boats and ships. We have to thank Shad at Charismath who made a special lesson just for you about time, distance and speed to help you tackle today's challenge. This lesson and many more from Charismath can be found at worldchallenge.club. The video about storing energy in the spring was provided by Twig Education, who have online learning resources for learners to access anywhere. We all look forward to seeing the results of your tests and experiments online at worldchallenge.club. So that's it. Have fun and I'll see you soon for another challenge.